So in a logarithmic function, fx is equal to b to the power x is the exponential, and inverse of this is called the log. And it is read as, we can read as log x to the base b. Log x, this log x to the base b, we read it log x, or don't write here log x to the base b. But this is called the base. When you are writing log, you have two things. This is base, here b is the base, x is the value whose log you have to find out. This is called the base. So log x to the base b. Okay, this is the main definition. And it is the inverse, as you have seen, it is the inverse of the function b to the power x.
Can you mute?
Mute.
I cannot hear you. Mute everyone.
Okay. So log is the inverse of this function, and last time we have seen this graph of this function fx. So graph of this function, if you will take bx, it will pass always from 1. So this is the graph of the function b to the power x. So log x is the inverse. So log x to the base b will be the graph which is reflected on this line, which is passing through the origin. So we can say that the graph of these functions, the graph reflection of other in the line y is equal to x. This is the line which is noted by y is equal to x. So this line will reflect the graph of b to the power x. Then we can get the graph of log x to the base b. So this is the definition of log x. Then we will relate the logarithmic functions or logarithmic form with exponential form. Okay, let us take some example to understand how to relate the logarithmic and exponential form. For example, if we have 2 raised to power 3, 2 raised to power 3 is equal to 8. You know that. This is called exponential form. This is called exponential form. And when you convert it into logarithmic form, if you see here in exponential form, this is the base and this is exponent, or you can say power, exponent, or it can be said as power. So when you convert this into logarithmic form, you will write log, and base will be same. Base here is 2, here also it will be 2. Only these two values will exchange. 8 will come left side and 3 will come here. So log 8 to the base 2 is equal to 3. 2 to the power 8 is equal, 2 to the power 3 is equal to 8. So log 8 to the base 2 is equal to 3. Similarly, here I will convert into exponential to logarithmic form. So if you see this one is the same thing, b raised to power y is equal to ax. This is what exponential form. This is exponential form. Okay. Now, if you convert into logarithmic form, when you convert it into logarithmic form, as I told you, log, you will write log, and base will be base, b will be as it is, only x will come left side and y will come on right side, and x and y will change their positions. Then it was base, this is exponent, here this is exponential form, and this is exponential form, and this is the base, and this is exponent. This is what? Base here, and this is exponent. So here if you see that base is same as it is, only the exponent will come on right side. This will exponent of the exponential form will come right side. So in simple, you can say that you can exchange the positions of exponent and right hand side value. Then this is the conversion. So without converging, we cannot find the value of log. So now we can find the value of any log by using this conversion. Let's see one example. Log, what will be the value of log 81 to the base 3? How to find this one? Okay. So when log you are converting, this b will be there, only y will come here, x will go there. Similarly, for finding this, our first step will be, we will take the given log equal to log 81 to the base 3 is equal to y. Okay. Then write in exponential form. Now it convert into exponential form. Write in exponential form. As I told you, exponential form 3, this is 3. 3 will be there only. This y will come left side and 81 will come on right hand side when you convert. Okay, understood? Now this 81, we have to check that 81 is the power, which power of 3 will give you 81? So you can see 3 raised to power 4. 3 raised to power 4, 3 into 3 into 3 into 3. 4 times 3 will give you 81. Then like this, if both sides we have property of equality for exponents. If base are same, then exponents are same. So base are same, then exponents will be equal to same. 3 raised to power y is equal to 3 raised to power 4, which will give you y is equal to 4. And what was our y? Y was the value of this log. So therefore, this is a sign of therefore, we can say log, we got the value of log 81 to the base 3 is equal to 4. Answer. Okay. So like this is the way of doing it. Just we have to let equal to write y, then we can solve. Similarly, we'll take more questions. Log, we have to find the value of log root 5 to the base 5. This value we have to find out. Okay. So what we will do, similarly that we have done in the previous question, same way we will let this log under root 5 to the base 5 is equal to y. Y or x, you can take x or y. Now write this in exponential form. Write in exponential form. In exponential form, as I told you, this 5 is the base. So 5 will be there. Only this y and root 5 will exchange their positions. Y will come here and root 5 will come on right hand side. Now root 5 means value of root 5 is 5 raised to power 1 by 2. 5 raised to power 1 by 2. Root 5 means 5 raised to power 1 by 2. Then by the property of equality for exponents, if base are same, then exponents will be same. Therefore, the value of y is equal to 1 by 2. So y was the value of this log we considered. We supposed the value of this is y, and y has got 1 by 2. So therefore, the given log root 5 to the base 5 is equal to 1 by 2 answer. So like this, we can find the value of any log. Find the value of log, question number C. Value of, we have to find the value of log 1 by 49 to the base 7. So same way, we will let log 1 by 49 to the base 7 is equal to y, and then write in exponential form. We get 7 as it is left side, and y will come left side, and 1 by 49 will come on right side. Sorry, 49. Now 49 should be converted into power of 7. So 7 7 is 49. We can write 1 upon 7 raised to power 2. And if you will bring this in the numerator, the power will change. This 2 will become minus. Exponent will be, the sign of exponent will be changed when we are bringing from denominator to numerator or numerator to denominator. So now base are same. By the law of equality of exponents, y is equal to minus 2. So we got the value of, therefore value of log 1 by 49 to the base 7 is equal to minus 2. Log 2 to the base 2, we have to find the value of log 2 to the base 2. So log 2 to the base 2, again, let log 2 to the base 2 is equal to y. Then write in the exponent form it will become 2 raised to power, this y will come left side, and right side 2 will come on right side, and this 2 means 2 raised to power 1. Then by the equality of exponents, base are same, exponents will be same, so y is equal to 1. So therefore log 2 to the base 2 is equal to 1. This 2 should be written small, this should be big. So log 2 to the base 2 is equal to 1, like this here written. So this shows that if you are writing also, you can remember that any log to the base same. If you will write here log 3 to the base 3, that will also equal to 1. Log of any number
N
to
equals
the
to
base
1.
same number, log x, that means you can say in general log x to the base x is always equal to 1. So like this is the guided practice. I suggest you to do these all 4 questions in the same way that I did. Okay, so you can do it.
Okay.
Now basic concepts of logarithm. That was the initially how to find the log and what was the meaning. Now there also it was a condition that b should not be equal to 1 and b should be greater than 0. 10, because there is no log for positive value, negative value, sorry, there is no log for negative value, that's why b should be positive and not equal to 1, because b if equal to 1, 1 upon 1, b log b to the base b will be equal to 1, b to the base b is equal to 1, log 1 to the base b is equal to 0. The following statements you have to remember, then we have to do the questions on these statements. What I'll show you what are these statements. Number 1 statement is log 1 means log 1 to the base b. Any base of log 1 is always 0. That means log 1 is 0. Base can be any number, and we have seen that just now. I told you that log b to the base b, I said x to the base x, same thing, is equal to 1 always. And the third result is if log b to the power x to the base b is equal to also x, and b, how I will show you, this is they have done, because if you will convert into exponential form you will get, I will show that one also. So we are going systematically all the four results. First we are writing log x to the base b is equal to also x, b to the power log x to the base b. How it becomes log 1 to the base b? If you will write in the exponential form, write in exponential form. This one convert into exponential form, write in exponential form. As I told you, b is equal to 0 will come left side and right side 1 will come. So b raised to power 0 is equal to 1, which is true because anything raised to power 0 is equal to 1. So that's why we can say log 1 to the base b is equal to 0. Similarly, write this also in the exponent form. So this b to the base b. So left side base is b, right side 1 will come, and this one this b will come on
Hmm.
right side. So b to the
On the
power
right
b is
side?
equal to 1. That is true. So that means
Okay.
this result followed by the exponential second result. Similarly, the third result also we can convert and check that whether it is correct or not. So similarly here base is b and right hand side is x. So that will come on exponents of left hand side, and left hand side b to the power x will come on right hand side. Are you understanding? So b to the power x is equal to b to the power x. That is true. So these are all are the true results we are getting. That means these are correct formulas, you can say. So you have to remember this because for the next exercise we will use this one. Similarly, here also write in the exponent form, and here b to the power log x to the base b is equal to x. So this is exponential form. So now you will write logarithmic form, not exponential form. This is already exponential form, so logarithmic, if you will write it in logarithmic form, so log, this base will be base and this right side x will come left side and whole term this will come on right side. So this will become log x to the base b. So that is also true. So we have to remember these results to find the values of log, applying these properties to find the values of log. For example, question number 1. Question number A, that is A question. We are taking question number A now. Evaluate each expression. Log 5 to the base 125. Log base 5, 125. This value we have to find. So by these properties, we can use the following properties to solve it. What are these properties? So how you can write this? We can write log base is 5, 25, we can write 5 into 5 into 5, 125. Now you can see which property is followed here. The log b to the power x, b to the power x to the base b is equal to x. This one. Formula number, I am talking about formula number 3. So formula number 3 says that log b to the power x to the base b is equal to x. So this is followed here. Here b is what? 5, x is 3, therefore its value will be equal to 3. Its value will be equal to 3. Got it? But I think same question we can do by the previous method also. Second
Same
method
thing?
I'm showing not given in your textbook, but the second method we will try with the
Okay.
second method. This is the first method where we use the formula. Okay, in the second
Okay.
method, that is our previous method. If we do it by that way, we will take log 5, 125 to the base 5 is equal to y and convert into exponential form. So this 5 will be here and right side will become 125. And 125 can be written as 5 raised to power 3. Base is same, therefore y is equal to 3. Therefore we got the value of log 5 to the power 3 to the base 5 is equal to 3. So we can do by this method, or either you can apply out of these formulas or you can go through the previous method also. But here you will
Your
have
voice is really low.
difficulty in question number 4. In question number, I mean to say question number B, this question. Okay. In this question, you can apply this exponential fourth part. So this question I will do now. B question. This question. Question is 12 raised to power log 4.7 to the base 12. Now we have to find this value by using this formula. Now B power, this one, fourth fourth property says B raised to power log x to the base B is equal to x. Correct? So this is similar to this one. Instead of B here it is 12. So directly you can use this formula to get the value of this equal to 4.7. Alas, 4.7, that's all. So sometimes we can use directly this formula. So we are using this formula in this new properties we are using to solve by these 4 properties. If the base of a log is 10, a logarithm with base 10, this is called common log. And on calculator you will find log. Log is written on the button that will be used to find the value of log. That is the natural log. Oh, no, not sorry, natural not. This is common log.